Bird Migrants by the Super Flower Blood Moon, May 2022. On the night of May 15th, 2022, there was a full lunar eclipse with a Birdcast, we'll talk about what that means, prediction of moderate migrant activity. The 2 nights before that, there was a prediction of high migrant activity. I attempted to moonwatch for birds on those 3 nights, but weather conditions, as you'll see, limited my opportunities on eclipse night, although I was able to photograph the blood moon. Friday's nocturnal bird migration was memorable. I'm first going to show you the blood moon, and then my nocturnal bird moonwatching experiences from Dana Point, California. So let's look at some definitions I found online. I show you where they come from at the bottom. The space.com says that a blood moon happens when Earth's moon is in a total lunar eclipse. While it has no special astronomical significance, the view in the sky is striking. It certainly was striking, as the usually whitish moon becomes red or ruddy brown. I was the only one on my block that was up there outside looking at that thing. A supermoon occurs when the full moon coincides with the moon's closest approach to Earth in its orbit. Supermoons make the moon appear a little brighter and closer than normal, although the difference is hard to spot with the naked eye. And why is it called the flower moon? Well, from this website, the Old Farmer's Almanac, which publishes Native American names for full moons, calls this month's full moon the flower moon, as May is known as a month when flowers bloom in abundance. This name was given to the moon by the Algonquin tribes, an indigenous people of North America. So there are the definitions. This was all over the newspapers. It was on NBC and NBC Los Angeles News. I found this on the internet, and I captured this frame. It shows you that on the night of May 13th, moonrise was at 7:40 p.m. In Los Angeles, already 20% of the moon was eclipsed. And then totality begins at 8:29, and you can see the rest of the times there. In Orange County, we're about 3 to 4 minutes before these times. So the full eclipse lasted quite a long time, and I was hoping that I could get pictures of birds crossing either the totality, or at the end when the Earth's shadow moves away from the moon. Did not happen. The first thing is, this is a picture taken with my iPhone from a viewing point in Dana Point, California. It's actually in the front of my garage at 7:35 p.m. The moon should have arisen in a couple of minutes right where we're looking, but there's a cloud bank there. Sunset was at 7:42 p.m. And the cloud bank kept coming closer and closer to me, and it was just a race between whether I could actually see the moon in the sky or whether the cloud bank would be completely over my head. And it turned out that at 9:15 p.m., I finally did get a glimpse of the moon. It was just peeking out from the clouds. I had to wait a little bit to make that transit go a little bit higher. Didn't want to move my tripod and my camera. And so here we are at 9:18. You can see what a pretty sight that is. Here is 9:32 p.m. I switched the camera to an astronomy mount and rotated the image because the camera's at an angle. It was about a 1-second exposure. This is 9:38. This is from my iPhone. I've enhanced it and have lightened it considerably. And you can see that that moon is starting to go behind the cloud bank. And it's really unfortunate because I didn't get very much views after that. So here's a little video just to show you the Earth's shadow, and that's it. Basically, it's really disappointing. Really disappointing. So let's switch to watching birds flying across the moon. And I have now 3 videos. This will be the 4th one. The first one is on bird migration against the moon using a Nikon P1000 camera. Then I have a much more detailed one about fall migration, showing information, examples, and filming protocols. And then last month, with a medium migrant activity, I produced this video where every single event that I saw, you will see on that night. And it was really a pretty interesting time. There were 2 really large flocks of birds that I was able to record. So the definitions of bird migrants are feathered vertebrates that make annual round trips between breeding and wintering grounds. And here we are in May, and it's the spring migration. Moonbirds, I call moonbirds. Many bird species migrate at night, and their silhouettes can be seen against the moon. And Birdcast. Birdcast is from the Cornell Laboratory of Ornithology. It's an important conservation tool, actually. It makes predictions about how many birds are migrating that evening, even their height possibilities. And so there's a lot of mortality of migration of birds, and this might be one tool to allow people to turn off lights, which confuse birds, and they often die by striking against buildings, lighted buildings. In any case, you can see that the forecast for May 13th, 14th, and 15th are there. High, and medium. Okay, we'll see what that looks like. So filming the moon in May of 2022, let me repeat some of the things on my previous videos. I used a Nikon P1000 camera on moon setting. It's a mode on the camera, and put it in manual focus. The camera was basically mounted on a motor-driven astronomy mount. Video and images were taken at a zoom of about 32 optical power. The videos were taken at 1080, 60 frames per second for 3 minutes at a time. That generates about 0.6 gigabytes of file per segment. And then I would stop the video, it would be saved, and then start another segment of about 3 minutes. I looked at all the videos on a large monitor, noting the segments that had flyovers, and recorded the time on the segment that the event happened. I did the viewing at least twice for each video segment to see if I missed any transits. I'll tell you about the statistics for that in a second. The monitor video program, however, probably showed the video at less than 60 frames per second, which might have reduced my ability to detect all the bird transits on these videos. So the validity of the technique, you might wonder how good am I in finding birds on film, on actually video, crossing the moon using my monitor and video playback programs. For the April 2022 Moonwatch, that was last month, I found initially 21 of the final 27 events, about 78% on the first look through the video segments. On the present one, the 2 nights that I did, May 2022, the Moonwatch, I found 88 of 109 birds, 81% on the first look through for May 13th, and 32 of 34, about 94% for May 14th. So I'm going to test your ability, if you think that's easy, to see moonbirds at this presentation's end. Give you an opportunity to do that. So let me look at some past statistics for you. On the fall migration, September 17th to 21st, 2021, I took out the camera equipment. Birdcast predicted low bird migration. I filmed the moon for a whopping 267 minutes, but I only found 42 objects were detected. One of them was actually a satellite. So there was about one event every 6.4 minutes. Only one segment of the 93 segments that I recorded had 3 or more birds, or events I'm going to call it, or sightings. That's about 1%. That's low bird migration. Last month, April 17, 2022, under a prediction of medium bird migration, I filmed the moon that night for 69 minutes. I got 28 events or sightings were detected, including 2 large flocks of birds, and that's why I'm using events. Even though there are lots of birds in one of those flocks, I consider that a single event. So there was about one event every 2.5 minutes. 4 segments of the 23 segments had 3 or more birds. Most of them are bird sightings, about 17%. Now, Birdcast has a way of showing you the data they collect. It's from radar, and also the predictions are done not only by radar, but weather reports, etc. And on April 17th, they estimate that in Orange County, California, there were over 88,000 birds in the night sky on April 17th. That's a medium bird activity. The present statistics are that the night of May 13th, 2022, under high bird migration prediction on Birdcast, I filmed the moon for 150 minutes. 109 sightings were detected, and about one event every 1.38 minutes. That was pretty spectacular. 16 segments of 45 segments had 3 or more sightings. So lots of bird activity. It's about 36%. And here is what they call their dashboard. On the right are some expected nocturnal migrants. You can do your own area. And then what happened last night. So this is the next day. I looked and found out what the statistics were for the night of May 13th. And let me blow up that section. You can see here on the upper left, well, first of all, over 500,000 birds came through Orange County, the estimate was, the night of May 13th. The birds, and this is quoting from this, birds usually begin to migrate 30 to 45 minutes after sunset, with the greatest number in flight 2 to 3 hours later. And that green line certainly shows that about 9:15, 9:30, that was the peak of migration, or at least bird activity. They also show flight speeds here, 26 miles per hour, and then there are a series of arrows pointing to the northwest, and that's where the birds are in the spring, seem to be migrating through Orange County. Now, they also show the altitude, probably from the radar. I thought this was very interesting, that the maximum height was about 4,000 feet. I don't know if that's an average or just a mode or whatever it is. And we're going to see something different on Saturday night. And then on the upper right, that graph will show you migration peaks over April and May, where most birds will go through spring migration. So lots of information there. On the next night, May 14th, remember it's supposed to also be high bird migration. It certainly did not look like it. I filmed the moon for 129 minutes. There were only 34 sightings versus over 100 the previous night. About one event every 3.8 minutes. And only 2 segments of the 40 segments had 3 or more bird sightings, only about 5%. And here is the dashboard for Saturday night, May 14th. Quite a number, reduction of migrants going through Orange County, now about 370,000. Again, the same sort of birds usually have greatest activity after maybe 2 or 3 hours after sunset. 28 miles per hour flight speed. Now, what's interesting is their altitude is very high on Saturday, and I'm beginning to wonder whether they're high enough to go out of my resolution of my camera setup. Maybe that may be another reason why I didn't see too many of these migrants. It's a possibility. That's a speculation. There is a neat Audubon magazine article about how to get the most out of Birdcast migration forecasts. I'm going to give you that link, and also we'll put it in the show notes. And they warn you, a word of caution, that while the forecasts are fairly accurate, about 75% of the time, according to this researcher, they are imperfect. Whether or not birds show up at your backyard or at your favorite birding hotspot is a different, challenging question. But that's the fun of it, trying to figure out the mystery of migration. In this case, the difference between Friday and Saturday nights here, it wasn't a question of my backyard, it was a question of birds overhead. And if some things I don't understand, that Orange County has a coastal habitat area, and then the Santa Ana Mountains are on the east side. Exactly what's the distribution of birds migrating over each of the parts? So I want to test your moon watching ability. Give you an opportunity to do this. I'm going to show you about a 2.5 minute out of a 3-minute moon watching segment from the night of May 13th. After 2.5 minutes, I didn't see anything going across the moon and in that segment. I had trouble setting up my equipment on Friday night. I forgot to clamp down one of the setting circles of the astronomy mount, and I fought to keep the moon centered in the camera's viewfinder for most of the filming. So the image is going to be a little jerky. I'm going to try to center it, etc. Well, that's more fun for the test. I mean, I didn't want to make the test easy. You will see the video at actual speed. Your job is to count the number of bird transits you see on the segment. I will tell you, this segment gave me the most problems of all the film segments in finding all the transits. I thought I had most of them, and when I got to this segment, I was really surprised. Initially, I recorded only 2 bird overflies, but on the second viewing of the segment, I found another 5. And then when I started to work with the segment to put it on this YouTube video, I found 2 more. For a total of 9 transits, I was getting a bird every 20 seconds. It wouldn't even surprise me that you might even find another transit that I could not see. So once you go through the video, I'll tell you that if you haven't seen all 9 events, to stop the video, rewind, and try again. They're there. You may doubt it. Did you see 2 of them? Did you see 5, 7 of them? Did you see all 9? After that suggestion, I'm going to show you parts of the video, and before each transit, I'm going to show you a picture where the bird starts entering and exiting the moon's orbit, or the moon's orb, and then play that transit of the video slowed down in 1/8 speed. Okay? In some cases, there are going to be 2 birds crossing the moon close together in time, and that's one of the reasons why you might have had trouble. You're going to have to shift your eyes quickly. I'm going to show you the video as taken. The camera is at an angle to horizontal on the astronomy mount. I haven't rotated the image to reflect what a horizontal camera placement would show. Every time you fool with video, my feeling is you reduce the quality. I don't want to do that for this test. Now, this is what you will see. You will see the moon that looks like this. The moon has a north and a south pole, but to the right, that's west in the sky. That's west in the sky, and to the left is east in the sky. And what you're going to see is a lot of birds when you see their track are going northwest. Going northwest. Okay, now let me start this video. And you can see all the movement. Take a look. Make sure you don't miss any of these birds crossing the moon. This used to be a technique that people used to figure out populations of migrating birds. Radar and the Birdcast researchers have much better way of doing it today. And people would just put out a telescope and record what they saw in short intervals. They did not film it like I am filming it. That crater on the right is Tycho. The crater toward the left is Copernicus. The dark areas are seas, the Sea of, I think, Serendipity, and the Sea of Tranquility. So you're racking up the transits, right? Can you imagine what you would see if you were looking through binoculars trying to hold them steady? The assumption is that the smaller the siding, perhaps the higher they are. It may not be a relationship about the size of the bird itself. And I think that's the end of that sequence. Now that you've seen this segment, how many bird transits did you actually see? More than the 2 I initially saw? 7 after I looked 2 times? Or the full 9 transits? And if you saw more than 9, that would be interesting. I'd like to know where they are in terms of the time sequence, starting with 0 time at the beginning of that video. I wouldn't be surprised if there are more bird events on the film. If you want to try again, stop this video, and rewind to the beginning of the segment. If not, we'll let the video continue. Remember, I've slowed this down to 1/8 of a speed. 5, 4, 3, 2, 1. Each of these 5 seconds, you're going to be 2 initially, showing you start and exit on the left side. And I guess I should start the video going. It's not starting yet. So you're going to see something like this. I'm going to show you where the time, first of all, the time, May 13th, 11 p.m., 11:18 p.m., and between the 19th and 21st seconds, there was a bird on the left side. Everybody saw that, right? And I'm going to show you the start and the exit. However, what you can also see is about the same time there was another bird toward the right. So you're going to have to shift. I'm going to show this for 5 seconds, these sorts of indexes, and then I'm going to show a snippet from the video that you saw. I'm going to add 1 or 2 seconds before the bird appears over the moon, and then 1 or 2 seconds afterwards, which could be some time, because remember, I'm slowing this down 1/8 speed, so it could be 8 seconds before you actually see the bird start to move across the face of the moon. So let me start this going. So you can see the second one is going to start right where those craters are. Okay, so here we go. First couple of seconds, nothing. Looking to the left. There's kind of a side view of that crater. There goes the bird. Out. Now that may be difficult to see. Before I do that, the other bird is already moving. There he is. He's about in the middle of the moon right now, going up toward the northwest. Birds that slice the moon, really narrow slices, could often be not recorded. Okay, here's our third example. It's going to start to the right of Tycho crater. You're looking to the right of it. Oops, it's already up there. Boy, I didn't see that at the beginning. Kind of disappears. You might want to rewind that. It is there. Okay, that's the fourth one. So this is the fourth one. It's going to start, and the bird's going to go right through Copernicus. So we're cutting off the bottom a little bit, but let's see where he is. There he goes. Going to be right over now, Copernicus. Look how small it looks. Must be potentially a very high flyer. Another one that's going to go right through the center of the moon, starting on the bottom. There he comes. In the middle of the moon. You can see the wing beats. Going over one of the seas. Okay, here is another one. It's going to start where those craters are. And there's another one that then's going to be on the left side. The one on the left side is pretty big, so you're not going to have any trouble finding that. But the one on the right is going to be another one of these small ones. There he is. Picked him up now. Now he's about in the middle of the moon. Going all the way up. And then you look to the left. And there's that bird that's flying in the same general direction of the high flyers. Now this is an interesting one, because this is going to go very quickly, and it's very blurry. So it's very close to the camera. And then finally here we have starred exit. It's going to come out from the craters on the bottom left. And let's see if it's going to do that as we record this. Here he comes. It's going to come right to the left of Copernicus, as you can see on this video. And exits. You see the wing action of that one. And is that the last one? I think that's the last one. So I hope you enjoyed that. This has been another of my JDW talks. I have YouTube talks on genealogy topics, census resources, Ellis Island immigration, natural history topics, including virtual birding field trips, which I consider this as a birding field trip, birding optics, Orange County birds, and also novelty zithers and biology songs. So get out and enjoy nature, and you'll see some really interesting things. Bye-bye.